Hi, Sergio. How are you doing today?
Hi, I'm doing fine, thank you.
Okay, Sergio. So, welcome to the Nutrias interview. We are going to perform this 45 minutes interview. First, you will introduce yourself. So, I want you to tell me what is your general background, uh, what has been one of the most challenging problems you have faced through your career. Yeah, just let me know uh, what what you have faced with.
Great. Okay, so my name is Sergio, as you already know, and well, as past experience, I have won some hackathon with two projects, and one of those was about child diseases, particularly autism. So we aim to help childs or children with some application that provides them with more interaction. And another project was about earthquakes. So basically, this project generates some alert to the user in case of an earthquake. So in this one, we connect IoT devices with some network infrastructure and also mobile applications. So that was a really challenging one. And more recently, I had an internship with Microsoft, which was also very challenging. um, I learned how to work with a more front-end frameworks and some networking tools, also cloud computing. So I think it was really interesting. So that'll be my background. And well, as you can see, like I like to generate some impact in people's lives. So I would like to keep doing that in this company that I want to apply. So that'll be it.
Okay, great. So can you elaborate on a technical problem you faced at Microsoft?
Okay, so in Microsoft, I had to develop this kind of complex function so that it generates some random data, but this random data should follow some pattern so that it fits into some some already built model. So basically, my work was to generate some sort of a smart random data stream for this model so that it can actually do something uh, of I don't know, efficiently. So I think that was the most complicated thing I did in Microsoft. So yeah, at that point I didn't know much about how to make this stuff. There were a lot of mathematics involved and a lot of communication between servers. So I think that was the most challenging thing there.
Okay. So you say you were handling data at Microsoft, right? Like streams of data of
Yeah, yes,
huge
something like
amount of
that. Yeah.
data. Okay, so you were handling data like this, right? Like a data stream.
Yeah.
Um,
Let's see. Okay.
you
Yeah, it was
generated not random numbers, right? Like
right.
let's say one thing. Okay, great. So at this company we face a lot with such problems as well. So I would like you to let me know how you can solve a problem like that in this company, right? And after that,
Okay.
I want you to code a solution for this problem. Is that okay with you?
Yeah, that sounds really great.
Okay, great. So let's say so in your past experience you dealt with this kind of problem. You had a string of data, right?
Right.
So let's say we have this stream of data and we want to calculate let's say the average of the last three elements of data. But we want to implement this in a class. So more engineers or more code people, technical people can use this class in order to build the products here. So yeah, what I want you to let me know is how you could implement this kind of this kind of methods and this class in order to help other engineers. at the company solve more problems. So let's say you are going to implement this class, right? And
Okay.
what I mean by moving average, as I told you, is let's say we are getting this number, like number one, and okay, I'm gonna let you know an example of how an engineer can consume this. And let's say he is creating an instance of your class, and then when he calls, let's say moving average that next of one, the result here could be one, right?
Right.
And then if he calls, and if we pass this at the constructor tree, means we are going to calculate only the three last average of only the three only the last three elements average. So then if we call, let's say 11, this is going to be 1 plus 11 divided by 2, this whole sum, 3, then it will be divided by 3, right? So yeah, uh, let's say you want to implement this class, and
Okay,
how could
great.
you do it?
Okay. Okay, so I understand that there is some well, we have to persist like these numbers that are like somehow inserted with this next function, and we have to compute here you're passing a tree, so I'm assuming we have to compute the last tree as you mentioned before. But well, now I wonder what happens with the first item. So for example, in your data stream, what happens if I then insert number 4? So what would be the output if I insert number 4?
Okay, great question. So if you are doing something like you say inserting here 4, then what this algorithm is gonna behave like is going to get rid of the last element like that, and then add the new element,
I
right?
see. Okay.
Yep.
Okay. Perfect. So basically, this number is like a window size which defines the maximum size of this. So I will never be able to have 4 items here, right? Just
Yeah, you will never reach more than
okay,
three
3 or less.
elements.
Right. Okay. So okay, that I think I understood this part of the problem. I have some maybe some clarifications with the input. So what if the window size is 0? What will happen here?
Oh, okay, what do you think can happen if the window size is 0? What?
Okay,
How do
so
you
if
think
the
it looks
window
like?
size, so I think if the window size is 0, like it will be always like an empty here, like empty array or something here. There will be nothing to
Yeah.
sum. So I think maybe we can return 0 or we can return an error. So I wonder what should we do in such case?
Okay,
Or if
let's say we won't have no one is going to use this with 0. We will write a constraint. So let's say we don't handle this case.
okay, okay. So discarded. Great. So um maybe another question that may affect the problem would be if we had negative numbers or or not.
Negative numbers were
Here, right? If we insert a negative numbers, can we have a negative numbers?
no, we will have only positive numbers.
Okay, positive, and well, of course, I assume here is also like a positive, right? So instead of here, I'm gonna write this just like greater or equal to 1.
Yeah.
So so negative numbers. So I will say it's never gonna happen. Perfect. I see. Okay. another question would be, can we solve this problem using extra memory, or maybe we are required to solve this in place or something like that?
We can solve this problem using extra memory. However, let me know how you can. Well, what is the first approach that comes to your mind using extra space memory? Extra
Okay,
space.
yeah. So let's say this is my first approach, and yeah. So what I'm thinking is that we can store these numbers, like literally all the numbers that come to the next function. So we can have some array inside the class that can store all the items. And every time we insert a new item through the next function, well, this is going to increase. But then we can literally make a window using two pointers approach. We can have like some L and R variable somewhere, and we can increase them at the same time with the window size. So to explain more in detail, I think it will help to simulate with this example. So really quickly, so I am thinking of creating these variables L and R. So they will start on 0. So then the first call will be 1. So right after that, we're going to have uh, our actually yeah like that, and then it will be inserted in array at position well the only position that it has right now. So then we will keep doing this. Then this will be increasing. Now the array will look like this. I mean like this. Then we will increase it. Now at this point, we already have a size of 3, right? So, well, we know that in the next iteration, or well, in the next call of this function next, we will have to ignore the first item. So we will have to increase L and also R. So now at this point, both pointers are going to increase at the same time, so that I ignore the first item. And this function requires me to return a double, which is the moving average. So what I will have to do in that point is to iterate from L to R exclusively, and compute the sum, and then divide it by the window size. So I think the time complexity for this approach, whenever we call the next function, will be something like this. So let's say we have n equals to r minus l. So the time complexity will be t of n. But we will have like several amount of calls. So if we define like calls number like this is number of calls. We can say that um, we will have something like number of calls times n. So this will be the time complexity. And as for the memory complexity, it will be the number of calls, because the number of calls will be the size of my array that I will be storing in the class. So this will be like that. So in time and memory. So well, I think that solution works. Do you think we can still improve the solution, or is it good to try to code it?
Uh, okay, is there a way you can avoid uh, use extra memory like this? Is there a way you can improve this array, like not using too many items, not adding too many items to our array?
Right. Right. So, yeah, because what I see is that right now we are storing like elements that we are not going to use in the future anymore. So that might be just a waste of space. So maybe instead of a single array, maybe I can use like a, a double-ended queue, which might improve the space. So this will be like the second approach. And with this one, we will do the same thing, but instead of just advancing through L and R, what we're going to do is to remove from left. So that will improve memory complexity because it will not be the number of calls. Now it will be just n, which is just r minus l. So yeah, this will improve in memory complexity.
So this is the
So
size of our window, right?
that
Again.
is the size of the window. Yeah, actually I can just
Okay.
write it here, window size. So we don't have to store all the elements anymore. So yeah, that's a huge improvement in terms of memory. And well, however, time is still the same. Uh, if I have to compute the whole thing in linear time. But I'm thinking that we can have another variable here, so like an extra variable in the class. Third approach I'm gonna call here. So I'll write here like extra variable, like to have a current sum.
And the second approach is using the QE, right?
Right. Yeah, we can
Okay.
just write it there, dq. So,
Okay.
so with this extra variable, my intention is to improve the time complexity, because what we can do is that we can, whenever we call next, we can increase current sum uh, plus equal to the given value, right? So that will be constant, and then if we exceed the window, then what we can do is to subtract the first item. So so it will be something like current sum minus equal, I don't know, first item. And well, with the DQ, we will also delete it after this operation. But well, the time complexity with this will improve to just C of n, which is the number of calls instead of number of calls times the window size, which is better. So as final, we have a time complexity of number of calls and the memory complexity of just the window size. So yeah, I think this solution could work. So what do you think about it? Do you think we still can improve it somehow? Or is it okay to just code it?
The complexity of this solution looks great to me. So yeah, feel free to code this last tiered approach.
Okay, perfect. So I will start creating my variables that I will need. So I will start with um, the DQ. So I'm creating this private because there's no need to um, to put it a public. So I'll have to I'll try to disable
What?
this
Why do you
uppercase.
think it's better to use a private variables instead of public?
um, because the user is just going to access to this function. So we were requested to just build the implementation of these methods so that the user can use it in the main method. So there's no need to access this DQ that I am building. It will be just like encapsulating this
Yeah.
uh, these variables.
Okay.
So
Great.
so
Yeah.
I was just trying to disable these capitalized words so that they don't get capitalized automatically here in docs. So okay, so I will continue with this. So DQ, this will be of type integer, and we will call it let's say window DQ. All right, and right after that, we're going to create our variable, which is going to be the window size. So int window size. So this will be the variable that I will receive from the constructor. And finally, um, we will have to maintain this current sum variable. So at this point, I have to question if we will ever exceed the value of the of an integer here.
What can we use?
So I was thinking that we can use, instead of just an integer, we could use this long to define this. So
Okay.
like current sum, so that in case we exceed this value, there is no overflow. So I think this could avoid that overflow.
And why not using a double?
Okay, so I think we could use a double because this next function returns a double. However, I think it's better to just maintain an integer here, not to lose a precision at the end, so that we can just make one division inside this double function next. So I think it's better this to use just a long.
Okay, because anyway, we are not using the floating
Yeah,
point
actually,
property,
it will
right?
never be a double actually too. So, so yeah.
Okay, sounds great.
Okay, so I will start initializing this value. So Windows size is going to be the size here that I'm receiving. And the other thing is going to be the current sum. This will start with 0, and there's no need to initialize the window DQ. It just starts empty. So now it's time to implement this next function. So here I will do the basic steps here, which are going to be increase current sum by the new value and append this new value to the window DQ. So let's see. So value is going to be, actually it's not value, it's current sum plus equal the value. So I think, yeah, here, oh, sorry. Okay, there we go. Um, yeah, and then we have to append the the new element at the end. So push back the new value. And now we have to make a condition where we exceed the value of the window size, right? So what we can do is that we can create this if condition, and we can check um, the size if we ever exceed our limit, which in this case is window size. And if that happens, then what we have to do is that we have to remove an item from left and also decrease it from current sum. So that's what I'm going to do here. So decrease current sum by the first item in the DQ dot front right here, and I have to also remove it from the DQ here. So pop back, I mean it's pop front right here. So yeah, that will clear the first item from the DQ. And finally, what I have to do is to return the sum of the items, which is current sum, and then that will be divided by the size of this. So then here I think I have to cast it so that we return double here. So DQ dot size, and here I am using the size of the DQ because the window size might be smaller than the one given, right? So
Okay.
so yeah, this will always maintain the maximum value as the given size. So I think this code should work. However, I think I need to test it at least with the test case you gave me. So I'll do a really quick test here.
Okay.
So I'm going to copy this here just to simulate those values here. Okay, so we will start by calling our constructor moving average, right? So we have 3. So this will start empty, then the window size will be 3, then the current sum will be 0. Okay, so now we have our first call of next, and our first call is going to be, so I'm gonna put this a little bit up. Okay, so our first number is 1. So right here, we have current sum plus equal val. So what we're going to do is that we will update current sum to 1, and we will then push back 1 to the DQ, and then we're going to evaluate this condition. Now, the window size is not greater than our limit, so we don't enter this if condition. So we just immediately go here, and what happens is that we have 1 divided by the size, which is 1, and that's the expected result, right? Which is just 1. So after this, we have the second call, which is 11. So now we have a current sum plus 11, which in this case is 12, and we just append it to the double-ended queue. So now we check again if the size exceeds our limit. It doesn't. So now our current sum is equal to 12, and then the size is 2, so this is the expected result again, which is 6, and it matches perfectly with this, right? So after that, we have a number 3. So we insert number 3 here, and we have to increase it to 15, and this it gets appended to the double-ended queue, and then we check again the condition, so it's not met yet. We have to do this again. So now current sum is 15, and the size of the DQ increased by 1, so we got 3, and this returns us 5, which is the right result for this one, right? So 11, it's 14 plus 1, 15, divided by 3 is 5, okay? So it's good for that case. And then the interesting case is this one, the last one, where we have to remove an item from left. So at this point, we have to add 4. So we have 19 here. We have to append it here. And we should enter this if condition. So if the DQ size is greater than our window size, which is true for this case because we have 4 and the window size is 3, we enter and we remove 1 from current sum. So current sum is 18 at this point. And then we remove the first item from the DQ 1, and it leaves us with a size of 3 again, which is the desired size. And then finally we have to return 18 divided by 3, which in this case is going to be 6, which is the desired result here. So 18 divided 3, which, yeah. So I think it works uh, perfectly. So what do you think about this? Do you think we have to test it with another case, or?
No, it looks great to me. So I am gonna ask you to implement another method. So
Okay.
let's say we want to, because this is happening always in our current work environment. So let's say we want to get the last elements here, and we want to implement something like, let's get the last n elements added so far. Yeah, how could you do that given your implementation?
Okay. So last n elements.
Yeah.
So well, we will have a problem with this one because if the n is greater than our window size, maybe we cannot recover all those elements. So
Okay.
maybe for this one, it would be better to use the first approach, which was using an array to store every single item that comes in the next function. Um, but it will have the complexity in memory worse. But if we are required to do it in this function, then I think that will be my solution um, to recover them.
Okay. And actually, one of our developers did something like this. So he did something like he just got the substring and he passed it here, like let's say from as you have here window queue size minus n to the current, well, minus 1
Mm-hmm.
to window size minus 1. So how could you help him handle the case you just mentioned? What could you do?
Okay, so well, I have this doubt first. What is the array here?
Okay, he was calling this he was using an array previously.
Okay,
Like let's say
instead of
here
the
there,
DQ.
he was using your first approach.
Okay,
Uh,
okay.
in our in our code base we had your first approach. So how could you handle this? My guess is that you will have something like that, right? How could you handle that case? As you say, what would you add to this code in order to handle the case where it overflows?
Well, that will depend on what do we want to do there. Because maybe if it overflows, maybe we can return what we have at the moment, so the whole entire DQ. Or I don't know if we can return an error or something like an overflow error, maybe. So what
Would you
we
use an Google? Would you use an if condition or something like that?
yeah, so yeah, we can add some if condition there if it overflows. So basically what we can do is just check if n is greater than the current window dq.size, then here we have to do something, right? So either return an error or return the whole dq.
We will return just an empty vector. But
Okay,
how do you think we can handle this using something like an exception, right?
right.
Okay, great. So yeah, this is all for on the technical part of this interview. So if you want to ask any other question, feel free to do it.
Right. Okay, so yeah, I do have some questions. So I'm interested in well, right now I'm applying to software engineer intern. So I would like to know what are the most common challenges that this position has in the company.
You will be definitely dealing with many problems like this one. I mean, maybe we are working on some projects and you have to develop some feature, and it entails you to go through our code base, which is actually kind of cumbersome and huge, and we have some problems like the last one I told you. Some we may not have some validations, or we added a new feature so fast that we didn't write some tests, or actually we tried to. However, sometimes we are shipping code faster than we expect. So yeah, you will be definitely doing some of your nuances will be related with what we have done so far. So as you did at Microsoft, we have many problems related with huge data sets, and yeah, you will be implementing this kind of algorithms, and also refactoring some code. As I showed you in the last function, you have to you have to deal with a fast changing environment here.
Perfect. Okay, so that sounds really interesting and exciting. So
Can you still hear me?
yeah, yeah. Can you hear me? I think I lost something of connection. Hello?
Hi, can you still hear
Okay.
me?
Yeah, perfect.
Okay,
Yeah,
nice.
so I was saying that it was a really interesting answer. So I'm really excited to get into this company.
Okay, great. So that was everything on our behalf, and hopefully uh, we will be letting you know the next steps through this process. So thank you for interviewing with Nutria, Sergio. Do you have any other question?
Oh, not for now. Thank you very much.
Okay, thank you for interviewing with us.
Nice. Oye, me acabo de dar cuenta que duró 33 minutos.
Sí, por eso le agregué la última parte de nada más buscar un bug o algo así.